All right, we have numbers. We will not be scared. We're trying to write the equation of the ellipse that has these two vertices, and it has that focus at 1723. Now you'll notice in all of these that the y value is the same, which means if the y value is the same, we're talking about having vertices right here with the same y value, so the center has to be exactly in the middle. The foci are going to be outside of that, and that means the major axis is along, or is parallel to the x-axis, so we're stretched in the x direction, which means that when we look at our form, x minus h squared over a squared plus y minus k squared over b squared equals 1, that means that a value is going to be bigger because we're stretched in the x direction. All right, so if I were to just try to get an idea about what's going on here, I have vertices at 1423 and over here at 3023. Okay, in and of itself, it doesn't give us the equation, but what it can do is it can tell us the location of the center, because the center will be the midpoint between these guys. And so the midpoint is just finding the average of the x and the average of the y's. So the average of the x values, so 14 and 30, you add those, get 44, and half of that is 22. And when you average the y's are the same, so you just get that value, 23. Okay, so the focus is over here. So let's see, this is vertex 1, vertex 2. My focus is 1723, so we're going to have to use him here in just a moment. So from this, we can go ahead and say that we have x minus 22 squared over a squared plus y minus 23 squared over b squared is equal to 1. All right, no problem. Because we're stretched in the x, we know that the value, as I go from the center to the vertex, is going to be my a value. And from 17 to 30, that is 13. If you go from, no, it's not 17. What am I doing? I didn't mean 17. I'm looking at the wrong number. So from 22 to 30, the value is 8. And so the reason I caught myself is because I said it should be the same distance if I go from the other vertex to that center. So from 14 to 22, that value is also 8. Okay, that's what it should be. So my a value is 8. So I'm going to erase that, and that's going to be 8. So 8 squared is going to be 64. Now the b value. Well, we don't have the b value, but we do have c, right? Because c is supposed to be this distance right here. So from 17 to 22 means that c is 5. Okay, this is useful. And we know that c squared is supposed to be the difference between these guys right here. Now, because we know that we're stretched in the x direction, that means the value underneath the x will be larger, so we can say a squared minus b squared here. So c is 5, so that means c squared is 25. A squared is 64. We've got to find b squared. So moving terms around, b squared is 64 minus 25. So b squared is, let's see, what is that? 39. Not the sexiest of numbers, especially when you look at what b is, which is the square root of 39. But that means that we can erase this b squared, and we can put in the value that we're supposed to have, which is just 39. I'm not saying why not the square root of 39, because b is the square root of 39. So b squared is just 39. Okay, so what does this mean? Well, let's get to answering our questions. The center we found is at the order pair 22, 23. Okay, Your vertices were already given. I don't need to write that again. Your other focus. All right, so remember, C is 5. So 5 to the left was one focus. 5 to the right, 27, 23, will be your other focus. Okay, so the focus, we already talked about the vertices. The length of the major axis. Again, you can look here. We found that A was 8, so the length of the major axis, 8 times 2 is 16. The length of the minor axis, we found that B is the square root of 39. So double that is going to be how far you were stretched totally from top and bottom. And then we have the endpoints of the minor axis. So again, we are stretching square root of 39 top and bottom from that center to find the endpoints of the minor axis. So it means the x is staying the same at 22, and the y value is 23 plus or minus the square root of 39. And now we can answer the question about the domain. So you see here my little picture. I didn't finish this out. I didn't actually graph this, but you would have something that looks kind of like this. Right? So then you can say, okay, my domain is from left to right, so from negative 14 to positive 30. Not negative 14. Where am I coming up with this stuff? Sorry. I think my eyes are jumping all over the place, and I apologize. So 14 to 30. My range is along the minor axis, so it's going to be the low guy here. So it's going to be 23 minus the square root of 39, and then 23 plus the square root of 39. There we go. All right, let's do one more. If I say that your foci are 33, negative 19, and 33, negative 27. And let's say the length of the minor axis is 6. Is this enough information for us to write the equation for an ellipse? And I say yes. I mean, I made up the problem, so surely it's going to work out, right? All right, so your foci, they have the same x. That means they are oriented up and down like this. So let's call this F1, F2. So that's 33, negative 19 above, 33, negative 27 below. Your center is going to be the midpoint of your two vertices. It will be the midpoint of your two foci. So, the midpoint of these two foci is going to be 33, and then the average of these guys. So, negative 19, negative 27 combined to give you negative 46. Half of that is negative 23. All right, so my center is 33, negative 23. All right, now since we have the foci up and down from the center, that means that this is going to be your major axis. And then the guy that's perpendicular to that is going to be your minor axis. And they tell us that the length of the minor axis is 6, which means we'll have points on either side of this. Now it tells me the length of the minor is 6. So that means each of these is going to be 3 units off from that. So from here, we can go ahead and say what the endpoints of the minor axis are. Because one of these is 3 units to the left, so it's going to be 30, negative 23. The other one is 3 units to the right, so that will be 36, negative 23. All right, so this is good. We still need to find out what my vertices are, but we know that my ellipse is going to be shaped something like this. Okay, it may not be stretched out that much, but again, general idea just to help us move things along. Okay, so we have, let's see, what do we have here? We know the distance from the center to a focus. It goes from negative 23 to negative 19. So this is a change of 4. And you can see that down here as well. From negative 23 to negative 27 is a change of 4. So that tells me that my C value is 4. My A value is 3. So we just need to find B, right? And because we're stretched in a vertical direction, the B value will be larger. So we can say C squared is B squared minus A squared. So let's see, C is 4, so that's going to be 16 equals B squared minus 9. So B squared equals 25, which means B equals 5. So to find my vertices, that's going to be 5 units up and down from the center. So 5 units up from the center means adding 5 to this, so that's negative 18. Subtracting 5 from this makes that negative 28. So I hope that you can see how that matches up with things. So my vertices are going to be just above and below your foci, which means that the length of the major axis is going to be 10. Because B is 5, double that, you get 10. And really we can pick off from this picture the domain. Domain is from left to right, which would be the endpoints of your minor axis. So from 30 to 36, your range is going to be bottom to top. So going from the lowest vertex, negative 28, to the highest one, negative 18. So negative 28 to negative 18. But what we should really do is actually write the equation for this, right? So we have our center. So it means x minus 33 squared over a squared. Now, remember that's underneath the x, so that's how far we are stretched in the x direction, which we see here as being 3 units. So my a value is 3, so the denominator here is 3 squared, so that's 9. Plus y plus 23 squared, because that's the y coordinate for my center. My b value is 5, so 5 squared is 25, and this equals 1. So there we go. Piece by piece, we were able to put all of this together. And yeah, draw your picture, put in the key information, figure out the orientation. That's very important. So knowing that the foci were located along the same vertical line means you're stretched vertically. Your center has to be the midpoint. The length of the minor axis will be perpendicular to that. And so you start measuring things, doing your addition and subtraction, and putting things in a place that makes sense. Now, the biggest thing you're going to have to worry about is going to be using this guy right here, making sure you put things in the right order, right? So we knew that the A, what's underneath the X, was for the minor axis. So that was the smaller of these two guys. So I knew that B was going to be the larger one, so I set it up in a way so that I wasn't going to have some pesky negative running around causing me issues, right? So again, draw the picture, put your points in, you're going to be fine.